So let's proceed with problem 3. Determine the temperature of the field winding of a series motor when its resistance had increased to 240 ohms after running for 2 hours. The field winding has a resistance of 120 ohms at 15 degrees Celsius and its temperature coefficient of resistance at 0 degrees Celsius is 0.004 per Celsius degrees. Again, in order to solve for this problem, we need to know or we need to lay out the given parameters. What are our given parameters, by the way? So we have the resistance, which is equal to 120 ohms at 15 degrees Celsius. And again, we have the given temperature coefficient of resistance at 0 degrees Celsius, which is equal to 0.004 per Celsius degrees. Okay. Unlike the two previous problems, for this problem, we are asked to find the temperature at the given resistance, which is 240 ohms. So again, in order for us to solve for the problem, recall that the formula is written as this one. Dapat, yung ating Rx and alpha x should have the same temperature as their basis for computation. But yung given natin na resistance, okay, is at 15 degrees Celsius. And yung ating given temperature coefficient of resistance is at 0 degrees Celsius. Using this formula, we need to plug in the values for us to know the equivalent temperature coefficient of resistance at 15 degrees Celsius. Okay? And plugging in the values into our formula, we come up with the temperature coefficient of resistance at 15 degrees Celsius, which is equal to 0.003774 per Celsius degrees. Again, let us underline this answer that we obtained. Now, there will be some changes or manipulation sa ating formula. But we are going to use the same formula that we presented earlier, which is equal to the resistance at the given final temperature is equal to Rx times 1 plus alpha x times the change in temperature. In this case, okay, meron tayo nung resistance at the unknown final temperature, which is equal to 240 ohms. Okay, i-plug in lang natin yung mga values sa ating equation. So, we have 120 ohms times 1 plus 0.003774 per Celsius degree. Ito yung nakuha natin kanina na temperature coefficient of resistance at 15 degrees Celsius. Tapos, we need to find the unknown final temperature minus the 15 degrees Celsius. Paki-input lang po siya sa inyong calculator, then shift solve. And with that, we obtain the answer, which is equal to 279.97 degrees Celsius. Now, I obtained this answer kasi I made use of 6 decimal places only for this one. Okay. Kapag in-store nyo naman yung value or kapag ginamit nyo naman yung whole value nitong temperature coefficient of resistance natin, you're going to obtain 280 degrees Celsius. And that is okay. Okay? So, with that, let us box your final answer.